Hello, and welcome back to the Quiz 7 demonstration for GIS 311 at the University of Washington, Tacoma School of Urban Studies. There are many ways to accomplish the task of finding and creating a shapefile showing only the vacant industrial or commercial parcels greater than 1 acre within 3,000 feet of Eatonville, Washington that have little to no slope. The next step in our process is to do a little problem solving. What is necessary? There are many ways to accomplish this task. This is just one. My suggestion is to first narrow our area of analysis to just Eatonville. So we should create an Eatonville, City of Eatonville, Washington shapefile from the data that we've collected previously. And we can do that with the cities in Pierce County layer. This is a very simple task of opening the attribute table, finding Eatonville, and if there was a list of 10,000 cities, we could very easily search by attributes, figure out which column or field has the city name. We could sort for name equals and perhaps type in the name if we knew exactly how it might be listed. And of course I did not. Eatonville. Perhaps I spelled it incorrectly. Eatonville. Name equals. And of course I chose double quotes instead of single quotes. I'll choose now single quotes, apply. There is Eatonville. It's also selected in the map. From here I can close the attribute table and export from the shapefile or from the layer data, export data. Choose the folder and let's call it City Eat for Eatonville. I'm going to add .shp so that it's automatically added into my map. Use the drop down to ensure that it's going to the proper folder, my data of quiz 7. And yes. Our city Eatonville has been added to the map. I can remove cities in Pierce. Because our objective is to include 3,000 linear feet from the city of Eatonville, our next course of action should be to create a buffer around the city of Eatonville. And that can be accomplished by simply navigating to Geoprocessing, Buffer, City of Eatonville, City Eatonville Buffer will work as a great name in our data K7, and you can see that it's automatically entered. Linear unit, 3,000 feet. The side does not matter in this case, but you could choose a specific side that you'd like to go. Planner as well is our default that we're going to keep, and there is no need to dissolve because there is only one buffer. Click OK, and City Eat Buff has been added to our map. We can see it right there. Now that we have a buffer, we can restrict the tax parcels Pierce to a very small area and get rid of all of the extra data that's in our table of contents and our mapping area. For this, we need a tool called Clip, which is also found in the geoprocessing. The input features notice I have my help showing. The input is the bigger piece, and that is the text parcels. The clip feature is the City of Eatonville buffer. And I can call this text parcels buffer. Will work. So I'm buffering the text parcels into my data quiz 7. And it happens very quickly. I close. I can now remove text parcels pierce. I don't particularly need the City of Eatonville. I'll just turn that off. I have the City of Eatonville buffer still. I can keep that on. And if I zoom to the City of Eatonville buffer, you'll notice that there is still the raster, our digital elevation model, that needs to be clipped. We cannot clip a raster per se, but we can extract by mask. So we will look for the extract by mask tool in Arc Toolbox. We can search by clicking Control F, extract by mask, and see what we get. In Spatial Analyst, we have extract by mask. You can click on the tool. The input raster is the only raster we have. The input raster or feature is our City of Eatonville buffer. The data will be stored in our data of case 7. And we can give it a name such as raster eat for raster Eatonville. Click OK, and our extract by mask is complete, and close. I can close my search tool. It looks like something may not have happened, but if I turn off the raster project, we can see that there is a layer beneath the other two. I'll remove that raster, the original raster, and now have the digital elevation model of the Eatonville with 3,000 feet of buffer added to it. We modified our map a little bit. It might be a good time to save. Save as in my quiz 7 using the drop down to ensure that it's going to my user ID maps folder within quiz 7 of quizzes in my current directory. Instead of data, I'll just call it something else. In this instance, we'll just call it extract because I just did the extract by mask, and it is saved. While not part of the analysis, I'm going to demonstrate how to perform a hillshade. A hillshade gives a nice visual of the digital elevation model that could be used in a map. I open Arc Toolbox. I'm going to pin it open for a moment. It's within Spatial Analyst Tools, within Surface, and there's an option for hillshade. The input raster is raster Eatonville. We'll name it H for hill, shade, eat for Eatonville. We'll leave the azimuth and the altitude as they are. We'll leave the model shadows unchecked and the Z factor as 1. the defaults. And the hillshade is added to our map. Click close, and you notice that there is a hillshade now. We can see the hills. It's not, it's a little blurry because we used 1 degree or 1 arcsecond digital elevation model, but it'll work in this case for our purposes. For now though, I'm going to turn it off. What we definitely need is a slope, because we need little to no slope for our greater than 1 acre parcel within 3,000 feet of the boundary of the City of Eatonville. So in this case, we'll use the slope tool. The input raster is going back to raster eat, not the hillshade. We want to go back to the original raster. We can call it slope Eatonville or slope eat for short. We will keep the output measurement as degree. We'll keep it as planar, and the z-factor will also be the default. Simply click OK, and our slope is created. At this point, their slope has quite a few different colors. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's divided into 9 different classes. We are going to reclassify this slope to something a little bit more easy to read. We're going to classify it into level, which will be our little to no slope, moderate, and strong slope. And we do so with the Reclassify tool. The Reclassify tool is also found in Spatial Analyst Tools under Reclass and Reclassify. Our input raster is the slope of Eatonville, and our values are brought in as they were previously, as shown in the map over here. Our first step to reclassify is to click the Reclassify button, or excuse me, the Classify button. These are the classifications again that were found in our map and also listed here under old values. We are currently working with our slope Eatonville, and we're reclassifying using this classification dialog window. We are breaking it down into 3 different classifications, which means we need to eliminate several of these breaks. To do so, we select the break by hovering, and when our mouse turns to the left and right arrow, we can click. It turns red and we delete the break. Click, right click and delete. Click and delete. And we do so until we have just 3. One, 2, 3. From there, we're going to determine that 0 to 1.1 degrees is level, or little to no slope. I'm going to move this break and then navigate here, and notice the break values are changing on the right side. I can get them approximate. So we now have 0 to 1.13 something. We're going to go from 1.1 to 8.5 degrees for our moderate, which is pretty close there. And then anything above 8.5 will be determined as strong slope. And sliding these breaks is one way to accomplish our task. Another is to just type in the values that we're looking for. Again, 1.1 degrees will be the max of our level or little to no slope. 8.5 will be our moderate, and then the last one we need not touch because there are no values above it. We could, I guess, let's try stretching it out just to see what happens. This might prevent what some students get when they sometimes end up with a fourth classification by accident. So this might help. I just moved it out to the right a little bit, so that's beyond where we were in terms of, notice the last value is 14.269. We have above that 14.37, so no values should fall outside of that range. Click OK, and we have new values of 1, 2, and 3 instead of the old values of degrees. So we're reclassifying to level, moderate, and strong. Remember, the 3 indicates the strong. One more step is to change the name. So let's change it to Slope Eat Reclass. And it's too long, so we'll change the name a little bit. Eat Reclass, which should work. We will not check change missing values to no data. It's not necessary. Click OK. The reclass happens. We'll click Close. And notice that there are 3 levels. Purple is our level or little to no slope. Green at the time, right now, is our moderate slope. And our very strong slope is 3. Eventually, in this analysis, we are going to use the tax parcels and select by location. So we'll select tax parcels that are greater than 1 acre, that are also the type that we're looking for, commercial, industrial, or vacant, that fall on little to no slope, or our value, any of our 1 values. To do this analysis, or to use the select by location, all of the fields that we use must be in vector format. Therefore, we must change our Eatonville reclass raster to a vector. So we're going from a raster, which is a grid format, to a vector or a polygon. So we're going to choose the raster to vector and take it from a raster to a polygon. To complete this conversion from a raster to a vector, or raster to polygon, we need to navigate to the toolbox, conversion tools, from raster to a polygon. The input polygon will be our Eatonville reclass. We will use the value. We'll create a new name. And since this is slope, we'll call it slope underscore eat for Eatonville and poly for polygon. Because we're going to be comparing our tax parcels to these minimum slope polygons, we do not want to simplify the polygons. We'd like to keep it as exact as possible. So let's turn off simplify polygons. And we need not create multi-part features. Simply click OK. And very quickly, the raster is turned into a polygon. In this new polygon, I'll turn off the slope Eatonville, the slope reclass. In the attribute table, the grid code is a 2, a 1, or a 3. We can see that by sorting descending. There's a bunch of 3. That's our steep slopes or strong slope. Our 2s are our moderate slope, and our 1s at the very bottom are our level or little to no slope. Let's take a moment now and label them as such. It'll be easier to understand our analysis. I'm going to close the table and symbolize our new slope Eatonville poly. I'm going to go with categories, grid code, add all values, turn off all other values. Ones as a label, I'm going to say or call that level. The twos, again, were moderate. And those designated a 3 were the very strong slope or very steep slope. The color for right now is fine. Click OK. So we can see where the level, the red or the maroon, is the color where the parcels will be selected if they're greater than 1 acre. They're already within 3,000 feet because they're within this buffer. But if our parcels land in this level area, they will be as candidates for our analysis or our final shapefile. As mentioned earlier, we will use a select by location. First, prior to doing so, we're going to use a multifaceted select by location by first selecting the slope Eatonville poly level areas. We can do so by opening the attribute table, select by attributes. In this case, we would like the grid code to equal the level areas. Equals, there are only 3, so I can get unique values and double click the 1. This will select all of the level areas as determined by us when we did our reclass. They are now all selected. All of these red areas are now selected. This will help us select the parcels that are within the level areas or little to no slope. We can choose selection, select by location, and we again are selecting from tax parcels buffer from the slope Eatonville poly, and we can choose, and we should choose, use selected features because we have the areas that we want selected. And we'll say intersect the source feature layer. We could be very specific and say are completely within the source feature layer, meaning the slope Eatonville poly, but because we're looking for a larger area, 1 acre, it's okay if part of that is not as level as the rest of the area. So we'll just choose intersect and see how it works. And we do not need a search distance. From here, we're going to click apply, and parcels in the tax parcel buffer will then be selected. Notice how the parcels are now selected. I'm going to close this window, and it's a little deceiving because we still have slope Eatonville poly items selected. That looks like the entire map is selected now, but that is incorrect. To clear this up, we could open slope Eatonville poly, open the attribute table. I'm going to make this smaller so it's easier to see what happens, and deselect or clear selection, and some of these blue lines will go away. So it's a little more clear what we're looking at. I will then close the table. Tax parcels buffer. In this attribute table, make it bigger, there are about 1,502 of the total 1,799 parcels that intersect with the level areas or little to no slope. Let's create a shapefile of these items so that we're dealing with a layer containing only those shapefiles that intersect our level areas. We do so by closing the attribute table, and exporting the data. Only those that are selected will be exported. And let's call this tax parcels. We'll choose the name from buffer. So tax parcels level, perhaps, and click save. And add it to the map. From here, we can turn off the old tax parcels. And notice that these are the tax parcels. And let's turn off the slope Eatonville. There's still quite a few parcels in here. So there are a couple options that we can run through. We realized that that only 200 or so were eliminated that were not on the level areas. So let's take it a bit further. If we're trying to select a location, it would be best that our location was completely level. So let's repeat this analysis only by saying or choosing only completely within the level areas. So first, we must go back and select by attributes, grid code equals 1, apply, and all of the steep areas are now, all of the level areas are now selected. We can do a select by location, we can choose, instead of tax parcels buffer, we could actually go to tax parcels level. Use selected features in slope Eatonville poly, which are the level areas. And instead of intersect, we're going to say completely within. Are completely within the source feature layer. And click apply. Let's now look at tax parcels level attribute table, and there are only 686, which is a much better number than 1502. We'll close, we'll click OK, and now let's export another layer, tax parcels level, wrong button, data, export data, and we'll have to choose a new name. Instead of tax parcels level, we'll say tax parcels within, because we did completely within. And our tax parcels are added back to our map, and they are only, as you can see in the image, only within the low slope areas, or little to no slope. We're almost done. The only thing we haven't determined is, and notice there are a lot of tiny parcels, we haven't chosen the commercial, industrial, and vacant areas, nor have we selected parcels that are greater than 1 acre. Let's accomplish that task. In the attribute table, there's a column that tells us the land use of each individual parcel. So we are going to select those that are commercial, vacant, or industrial by using a select by location. Or, select by attributes. The name of that field is Land Use DE. So we need to find Land Use DE equals to, or equals, and let's look at the unique values within this field and choose which one of the options are vacant, commercial, or industrial. And now that we have much fewer attributes, this will be an easier task. We could actually go through and select those greater than 1 acre first, which, upon thinking about it, might be an even better idea. So let's hold off on the land use. We'll click close, and let's instead worry about the acreage. Right now, there is no acreage information in our layer, but we can easily determine that. Let's add a field, and since it's a number, it's going to be a double, but we'll call this area acres with an underscore. It'll be a double, and OK. I always choose double unless it's text or a date. From here, to calculate area acres is very simple. Calculate geometry, click yes. Instead of units being square feet, we'll change it to acres US, and OK. We'll say yes, that we're calculating outside of an edit session. And our area acres has been calculated. From here, we can do a select by attributes to pare this down to those greater than 1 acre. By selecting area acres greater than or equal to 1 to satisfy greater than 1 acre in our deliverables. Only 54 out of 686 were selected, which makes it a lot easier for us to determine which are the types of the land use type that we're looking for. So it was easier to go about it this way, calculating the acres first. With those parcels selected within, let's export those parcels. And we'll name it tax parcels acre to help us remember that they're bigger than 1 acre. We could actually do a GR8 for greater than acre. Click save, OK, and it is added to the map. I'll turn off the tax parcels within. I could actually turn off raster Eatonville. We'll get the toolbox out of the way. We now have 54 parcels that are greater than 1 acre within only the level or little to no slope areas. Our last objective is to find which of those is commercial, industrial, or vacant. And remember, there's a land use DE field. Right here. So we'll use that to select by attributes. Land use DE equals, and let's get the unique values. And choose those that are commercial, vacant, or industrial. Vacant land, undeveloped, that's vacant. I have land use DE equals vacant land, undeveloped. I don't just want to stop there because there's probably other, and there might not be. There are no other options in our data. So going to 1 acre made it a lot easier in this selection process. But let me explain. If there was another, let's say there was one called commercial, and I wanted to add it, it would make some sense to say land use DE equals vacant land undeveloped and land use DE equals commercial. However, what we'd then be saying is the name of land use DE would need to equal vacant land undeveloped and commercial. And in no way is that possible with our data. There is only one line in here. It would never have two in one row. So what we would have to do is use the OR button. And we wouldn't be able to just say commercial. We would have to say OR land use DE equals, and then double click on commercial. Now understand, don't get confused, there is no commercial option in here, so we won't click on it. I'll just back out of this information. But if there were two, we would not be able to use and. We would use or. Land use DE equals this, or land use DE equals this, for as many as there are in our data. The way we went through this process, we were able to eliminate all of them except for one. In this case, we'll click apply, and there were 9 selected. We can close the table and export our final shapefile. Export data. And we can call this our user ID. So I'll call mine GWL GIS underscore POSS for possible, PARC for parcels, and EAT for Eatonville. Click Save, click OK. Yes, I want it in the map. And there are our parcels. It'll be easier to see if I turn off Slope Eatonville Poly. And these are our final choices. We are done with the analysis. I should save my map. I'm not going to produce a map for this. For the lab, you will have to produce a map, and that's where you may want to use the Hillshade. And while I'm here, let me show you how to symbolize the Hillshade. Notice that these parcels are in flat areas. They're not on the steep slopes. Let's symbolize the Hillshade just very quickly. Symbology, let's right click and turn off graphic view. And there's a way to symbolize it with a brown light to dark that works very well. We'll search for brown light to dark, apply, move this out of the way, and we can see the land. Notice though that this is inverted. It looks as though that this is a plateau. So let's invert, click apply, and now it looks more realistic. This is a low-lying area and this is a ridge, and we could turn on the slope. Oh, we can't with this on, but this is a much better view. We'll click OK. I'm going to turn that off for now, or leave it on. It doesn't really matter. So I'll save my final map, save as, type in the word final. We're pretending that this is my final map. Yours would be much more beautiful, of course. Final. Save. Let's just verify we have our map document property selected. We do. I have not completed these. They should be complete, but for now it doesn't matter because this is just my demonstration. The last thing we need to do is submit our deliverables, and that would be these parcels in a shapefile. This shapefile parcels zipped up just the shapefile, not the map. To do so, we're going to use, of course, Windows. I'll explain how to do so. The first thing I need to do to zip up just this shapefile, again, not the entire map, is close ArcMap. I'm going to confirm to save it again. Within my 311 quizzes, I've got my quiz 7. I double click on quiz 7. Normally, you would right click and send to compress folder. But in this process, because we have the rasters, which are very big, we're just submitting one shapefile. And the shapefile is in the data folder. We'll open the user ID, open the data, and there is my user ID, possible parcels, Eatonville. Notice there is no schema lock. If Arc was open, there would be a file that says lock, but you should be able to find your user ID with possible parcel Eatonville or whatever shapefile you're zipping up. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 different components. This is what you're going to zip up to submit. You will submit something similar in Lab 7. The easiest way to do so is to create a copy of it and put it into a folder. Let's create a new folder. I'm going to give it the same name, Parse Eat, and then move or copy, I should say copy, all of these items into that folder by right-clicking, copy, opening the folder, paste. From here, I go up one folder and zip this user ID possible parcel Eatonville. I right-click, send to, compress folder, and a new zip file is created of my folder, which is up here. If I sort by date, it'll pop right up at the top. This is the file that you will submit. Yours will be similar for Lab 7. And this completes Quiz 7 for GIS 311. If you have any questions, feel free to email me. I'd be happy to answer them. If you like this video, please feel free to subscribe to see whenever I upload future videos. We are now accepting applications to our GIS certificate program for the next year, and also our Master of Science in Geospatial Technologies. We're always looking for great students to join our programs. Check out our website, which are most likely displayed on the screen somewhere. Thanks for watching. I hope this was informational.